Hello, my name is David Ehrbar. I'm the designer of the Serpent F110 SF4 Formula 1 car. I started last time a series where I explained how to rebuild the dampers of the car, and today I want to continue with the rear differential and explain a few features to you. Okay, so removing is simple as always, just get it out. Okay, the first feature that everybody sees on the first view is we use two different bearings. Left is a standard bearing and the right is a 8mm bearing. So we have this bigger diameter here, which actually helps a lot with the durability of the rear shaft, because I mean it's the most loaded part of the shaft, and it's just a bit thicker, so it will hold quite well. I will explain a few more details later. First, let's rebuild it. So many people ask me why I still run the Ball-diff and not like the X-ray gear diff, or why we don't make a new gear diff. The point is just our Ball-diff works so well, and from a performance point of view, it's you don't get better performance compared to a good Ball-diff. At least in my testing, it was all the time when I compared it. I mean, it was many times it was very similar, but I was never really faster. The durability of this diff is very good, but I will show you now if we replace the diff washers. I mean, normally they run forever, but I just show you anyways. If you get them fresh out of the bag, they are, can you see, they are a little bit greasy, but they are already like they have a mirror finish, so they are very you don't need to sand them or whatever. Just take them out of the bag, clean them with brake cleaner or whatever, and you're ready to go. This is a very nice feature, as nobody likes this kind of work on the car. So you can see this is ready for driving, for racing. Okay, for the balls, I just put them on a paper, on a tissue, and use some isopropanol to clean them. You can also use brake cleaner, it doesn't really matter. Just basically you just need to remove the grease and of course the dirt. But I don't like to touch brake cleaner so much with my hands, so I prefer isopropanol. Yeah, and if the other parts are dirty, just clean them. Yeah, in my case, I mean, they're still like pretty clean, but yeah, not so much to do now. Take the, I have a fresh spur gear now, so I just change the bearing from the old to the new spur gear. By the way, at the moment I run 64 pitch gears. in the past I was always using 48 pitch, but at some time I changed that because actually I want to run the diff under the body shell, and there are all the 48 pitch gears are bigger, so I need to cut out the body shell for the gear, and I didn't want that. So actually, finally, after 20 years of racing, I changed to the finer 64 pitch gears. I just put a little bit grease and distribute it with a screwdriver. You really don't need a lot of this, just that the surface is a little bit coated. And yeah, then put the spur gear on, and then just put the balls in. I always run 18 ceramic balls on the outside diameter. You can see we have 2 rows, and the outside row just fits on the diff washer. So on the outside you need less preload to transfer the same amount of torque, and by that you get more durability out of everything. And yeah, so also you have 18 balls instead of 12. On the inside you have 12, on the outside you have 18. So yeah, it is normally you never need to replace any parts there. Yeah, this you have to rebuild it only to clean it. Otherwise you can run it for several races at least. Yeah, you need to clean it, but you never need to replace anything normally. Okay, put all the bearings back in, and yeah, well, of course the second washer. I put a little bit grease on the outdrive, because otherwise the washer just falls down when you install it. It just makes life easier because you can turn it around and it don't fall out. So I have still the bearing here. So okay, it's inside. Now I reinstall the second bearing for the outdrive. Then comes the thrust bearing. Just get the spring out. We have a thrust bearing here, which gets which transfers the axial thrust from the screw. It's a quite simple to rebuild by that, because I mean, this is maintenance free. It's closed, so you don't get dirt inside, and it lasts forever. I mean, this is really simple. Just throw it in, and then we have 4 of the cone washers. These act like a spring to make the adjustment of the screw easier. Actually, you could also run standard washers there, but I mean, it's a little bit easier with these. So you have a wider range for adjusting. So there's a trick. You always basically you form 2 packages of washers. So it's like I show you the picture on the computer. Okay, here we have the same shaft on the computer, and yeah, let's do some magic. So you can see here we have these washers, and you can see how they need to be aligned. So they work in a way that they put the force from the screw to the thrust bearing, and the thrust bearing transfers the force to the outside of the ball bearing and here to the hub. So there is no force on the normal ball bearing, and actually you can do some fine adjustment of the diff with the force here with the washers. So you just take all the screws and put them in. The simplest way is just take the screwdriver, put them all on that in the right order, and once you finish that, just put the screwdriver on the screw here and let them slide in position. Just need to make sure that you don't lose them. Okay, so now they're in. So, and then take the nut and tighten it. Yeah, there's no need to over tighten it, but at this point you just need to close it. You adjust it later. Yeah, put the outdrive back in. Need to see where the screw is. Other side here. Yeah. Screw need to align with this hole. Then you put the pin in. The pin has a flat spot, so just have a look on where it goes. That's, simple work. So, closed. Okay, this was the assembling. Now let's adjust it. My way of adjusting is, I just take let's put the camera up. I just take the wheel before I put it on the car. I just put the wheel with the outdrive on. Tighten the screw. This is just like a clamping mechanism, so you don't really need to care about where you tighten it. Just put it on and close it and finished. So on the right side, I just put the wheel on. Oh, I was a bit too quick, of course, because I already put the outdrive on, and for adjusting you don't really need it. So I put the wheel on. I hold both wheels, and I hold the diff with 2 fingers. Basically, I take the one hand and hold the wheel, the right wheel and the gear, and then I turn on the left wheel. And basically, you can feel the maximum amount of torque that the diff can transfer during driving. So yeah, in my opinion, it should always be in a way that you never, that the diff never really slips on accelerating. I mean, of course, when you are cornering and one wheel is unloaded, then the wheel it can slip. But it should never happen that the diff itself slips. Like you see now, I hold it here and I can still turn the wheel quite easily. So I just remove the wheel, tighten here a little bit. You have to be quite careful here. It's like 1/8 of a turn that you adjust at once, and then you check again. And this is just, I mean, you need to get a certain feeling for it, but yeah. Just try to imagine how hard your car can accelerate, or how much force the tires can transfer to the ground, and basically try to close it more than that. So, okay, now it's good. Yeah, now you can put the outdrive back on. As I said, just align the screw here, put the pin back in, and tighten it. Of course, of course, to install it, you need to open that clamping screw again. Oh, one more thing. When you check the diff, you will also see, when you check it like this, you will also notice whether your clamping screw here is tightened enough. Because, I mean, it should not slip while driving, because otherwise you will lose your left wheel. Okay, just put the shaft back in. On this car with the wing to chassis mount here, you need to put the pod slightly up, but it's really, I mean, you will realize that quickly, just to get the gear over the wing to chassis mount. Okay, just put the wheel back on. Try to tighten the screw without, I mean, it should not have like a axial play here, the shaft, but it should also not be preloaded. So it should be, it must turn easy. So I just put it in place so it is in position, and then I tighten it without touching the right side. So the right side is free. So I have no play here, and still I can show you when I have both wheels on. Still it can rotate very, very free. Yeah, I can show you by, I mean, you can do a last check with how much force you need to turn that wheel. And if you are not sure if everything is free enough, just remove the pinion. I just put it, can you see it? I put it to the side, so it is not in line with the spur gear anymore, and just turn it, and you will see, okay, this won't stop. So it's actually running very free. And at the same time, there is no play in here, which is, yeah, I mean, better than to have play here. But you can always check, with this you can check if it's running free or not, and yeah, then if it's like that, you will have a perfect diff. And yeah, I will show you one more. I mean, you see, I'm using the carbon shaft, which is obviously lighter than the aluminum shaft, but it's also a lot more durable. And I show you some design details why it is that strong and that good. So here we have the shaft on the computer again. This time you see there's yeah, only the shaft. We have analyzed for quite some time different carbon shaft designs, and we have seen many problems with this insert coming loose, or with the shaft breaking where the pin goes through the shaft, the pin here. So we came up with a design that solves both problems. First, there are two critical things on the carbon shaft. One is the bending force here at the pin, because the carbon shaft it's drilled for the pin, so this is the weakest spot, and at the same time it's the biggest bending force, or bending tension in the shaft. So usually it breaks here. And the other problem is that this insert is loaded quite a lot by the screw, by the preload of the screw. So it's not so good for gluing. And yeah, so no matter how you glue it inside, whether you take a hollow shaft or you take a solid shaft and drill it, you will always get this problem of the insert getting pulled out when you tighten the screw. Okay, we have a design where the insert goes all the way through until the pin, so it cannot get pulled out. It's really strong. And yeah, of course, the shaft is very lightweight. It's hollow carbon fiber. And yeah, we reinforce it exactly here where the biggest load is and where we have the drilling for the pin. We reinforce it by putting the, I go back to the normal view, by pulling the larger diameter through the bearing, so it gets reinforced by that. So you don't need to worry about breaking the shaft. It's really strong. So I hope you had fun watching this video, and I hope I could help you for your racing and practicing and everything. And yeah, see you next time.